here. So if you want to check this, if you want to check that if you don't like 45.56, put in the first term and then say, I want to times by, what's the ratio here? 3/2. Times by 3/2. Because if you do it like this, if you put the number in and then you do times 3/2, all you have to do is, that's the second term, third term, fourth term, fifth term, 6, 7. There it is, right? You could just keep going. Actually, you can go 8, 9, 10, 11, 12. If someone asks you for the 5,000th term, you don't want to do it this way. But if someone asks you for the 7th term, you can check your answer that way. Okay? I don't want you to approach these as a, here's how you have to do something. You should be able to do both those things, right? Anyways, the other ones are there, 1/9, 4/9. This one's probably tough because it's hard to tell even if they're getting bigger or smaller here. 81/16, 27/8. You divide any two terms there if you have to do it that way, like 27/8 divided by 8. And if you're doing that on the calculator, that probably is not so nice, right? 27/8 divided by 81/16. Don't just do it like this, 27 divided by 8 divided by 81 divided by 16. What's going to be the problem there? What order is a calculator going to do this? Calculator doesn't make grade 8 order of operations mistakes. So if you punch it in like that, what does it think you want to do? Yeah, like divide them all one at a time. It's going to go 27 divided by 8 and get that answer. That's good. That's what we want to do over here. But then it's going to go divided by 81, get an answer. Then it's going to go divided by 16. Whereas what you actually want is you want it to do 27 divided by 8, get an answer for that. That you don't need brackets around, but the bottom you do, right? Because you want it to divide 81 divided by 16 first. So even though you write it without brackets, that's what you want, right? 2/3, that's the 2/3 that you're looking for there. When you have an expression like this, it's implied that there's brackets around it, so you should put those in on the calculator, even though you don't write those. Continuing along here. There's various ways to find this out. If you want to know how many terms are in that sequence, like I've given you a term here, but you don't know what position it is. If you want to solve that, you start with 32. You times it by 2 to the n minus 1. That's the general formula. Some of you are asking about, do I need to use logarithms for this? Because you put in here 16,384 equals 32 to the 2n minus 1. And you divided and you got 512 equals 2 to the n minus 1. You can use logarithms there, but you shouldn't have to, because if this works, this has to be a whole number here. N is 1, 2, 3, 4. It's whole numbers. Right? If we're counting objects, we don't use decimals. So this has got to be able to be solved by what you learned in equating the bases. That's 2 to the 9th equals 2 to the n minus 1. Right? So don't forget about that. That's one of the reasons we looked at that. If 2 to the 9th is 2 to the n minus 1, 9 is n minus 1. So n is 10. Okay, that's where 10th term comes from. This you can solve the same way, so I won't bother writing it out there. You can use logarithms, though, if you don't see that this is a power of 2. This one started to pose some problems for people because it seemed like you didn't have the first term and you didn't have the ratio. There's lots of different ways to do this. I really don't want you to kind of approach this unit as a, no, how was I supposed to do this again? I can't remember the recipe to do this question. I want you to be able to think your way through it, and I think some of you were pretty successful at that. Here's the different approaches I saw people do. One approach was to say, well, I've got the 4th term, and I've got the 7th term. Can I just chop this off and pretend that this was the first term, and then that would be the 4th term? Absolutely, that's a good way to do it. Because then you can use that formula, right? Term n is ar to the n minus 1. So if this was the 4th term, I can fill this in here, right? 1458 equals ar to the 4 minus 1, or in other words, ar to the 3. I got this negative 54. and just solve for what you have, right? You have one equation with one variable. You know how to solve that. Divide by -54. Take the cube root of each side. That's one way to do it. Another way to do it is this. Sorry, you probably were writing that down, weren't you? Because you're all such keeners that you want to copy down every thing. Oh, it's a pain re-undoing that. Okay, never mind. Another way you can do this here. Another way you can do this is if you don't realize you could start that. What you could do is you could write an equation for each of these. If you realize that you have two unknowns there, right? You don't know the first term and you don't know the ratio. What you could say is you could say -54 is AR to the, how many jumps does this take? 1, 2, 3, right? AR to the third, or you could use the formula. Two variables, that doesn't work. You could also write one for the other one. You could say 1458 equals AR to the, what would that be? How many jumps do I need to get to that one from the beginning? You need 6, right? It's the 7th term. You need 6 jumps to get there. Two variables, but you have two equations. This is not necessarily like something you did in grade 11, but it follows from what you learned in grade 11 about systems of equations. If you have two equations with two unknowns, that's enough to solve it. What you can do, you learned you could add two equations, you can subtract two equations, you can do things like that, you can multiply equations. Here's something you didn't know, but what you can do is you can divide two equations. If I divided these two equations, the reason it would work nicely is because if I divided that, what would I have? AR to the 6th divided by AR to the 3rd, what's that going to leave me with? Just R to the 3rd, right? AR to the 6th divided by AR to the 3rd, right? This would cancel. 3 of the R's would cancel. You get R to the 3rd. Over here, you'd get -27. That is, I'm not saying it's the way to do it. I'm saying it's a possible way to do it. Once you know the ratio, it's easy because you go and plug it in and you figure out what you're going to figure out. All right, there's the common ratio, and then you can go back and find the first term by subbing it in. Pick either one of those, substitute it in, and work it out. These are harder problems. As you progress, they're harder problems. Don't sort of memorize a method for doing these, because you're not necessarily going to get one that's the same, right? The same goes for this one. Different people, and I was quite surprised and pleasantly surprised at how you were able to kind of think your way through some of this. I've given you, this gives you 3 different expressions for 3 terms. I think a lot of you will have success if you try to make a list. If you're not sure, make a list of the things you know. As in, what is A? Well, it's X. I don't know because that's what it is. What's the ratio? The ratio you get by dividing any two terms. So even though you can't see it as a number, you can write an expression for it. X plus 5 over X. Or you could write it as the second two terms, X plus 9 over X plus 5. How many terms are there here? Well, if you're talking about you could say if you got term 3 is X plus 9, in that case N is 3. So some of you filled out a formula, this formula for it. You worked from that and you said, well, the first term is X. The ratio is this thing, X plus 5 over X. Term 3 is this X plus 9, and then so this is 3 minus 1, it's 2. You've gone from an equation, whoa, it's not good. You've gone from an equation that has, didn't realize I could erase the blue stuff. You've gone from an equation that has a bunch of variables to one that has one variable. If you write an equation that has just X in it, that's the only variable. All right, come on. All right, I thought the blue was permanent there because it was before. One more. You've gone from an equation that has a whole bunch of variables to one that has Only one. It appears a bunch of times, but it's only once. You can solve that. You know how to solve equations like that from grade 10 and 11. That's okay. I can split it apart, but thank you. The other way you can approach it is you can set up an equation just by having two different expressions for the ratio. If you have two different expressions for the ratio, you can write a proportion like that. If those are both equal to the ratio, then x plus 9 over x plus 5 has to be equal to this.